Microphone check 1 2 1 2. It's your boy the NetworkBruh back in the building. LiveLab episode number 111. 111 live streams. We back into it. This should be an easy one. This is going to be done in Packet Tracer. Yes, it is an Encore lab in Packet Tracer. If you have the Cisco's lab manual, the CCNP Encore one, you'll see they added this as one of their labs. So yes, it is a CCNP level lab, but it's fairly simple. Some of the show commands might have your head spinning or whatever, but I'm gonna take a screenshot of this because y'all know I like doing my annotations and stuff. So that way when we explain this, we have look at this topology right here, right? So you can copy this onto my favorite topology or network diagram application, Microsoft Paint. Let's see here. Let's go ahead and paste that bad boy. Hit me with a bro in the chat if you can hear me. I know sometimes microphone be messing up sometimes, or I'll have the wrong microphone set up. Anyway, it's your first time tuning in. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. And I hit you with these sound effects every now and then, right? Let's see if I can bring that up. Come on, man. This phone, I really need to get a new phone, man. Killing me, man. Anyway, what was I going to say? I'm going to tell y'all something. I'll give it a couple more minutes to tune in. If you want to get a copy of this lab right here, so we could do it together. Jesus, come on, man. Just had it on there. We could do this together. Y'all can point some things out. I can point some things out and let y'all know what I learned. I forgot to look up the difference between IPv6 router command and the IPv6 router OSPF command and the router OSPFv3 command. I forgot to look up that. Maybe I'll do it during the stream. Y'all remember yesterday we tried to do that. But anyway, this is going to be a multi-area lab. So we're working with OSPF version 3 again, which is for IPv6, right? But we're going to be working with multiple areas. Yesterday, we worked with single area OSPF version 3. Today, we're doing multiple areas. Why is that? Because we have multiple areas. This right here is area 0. This down here is area 2. And over here is area 1. Right? So we got these guys right here, which is going to be considered our, ABRs, which stands for area border routers. So very similar to IPv4. It's just that we're going to be working with IPv6 addresses. And not only that, with OSPF version 3, you don't have to work with the network statement. So thank God we ain't got to work with these 128-bit. Can you imagine if we had to work with network statements with 128-bit addresses? Oh, Jesus Christ, man. I have a hard time with just OSPF IPv4. Got Diane Foster in the building. Appreciate you for tuning in. This should be go ahead and you can download this lab from my Discord server. So if you're not joined to the Discord server, here is a link to the Discord server. And then you could get a copy of... Jesus, didn't I copy it? Maybe I didn't. You can get a copy of this lab so that way we can do it together. So I'm going to give it a couple more minutes for some people to tune in. In the meantime, let's see what we got in the IT industry. Put that in the IT folder. News. We got Network World. This is my favorite one. I got one of my favorite sources right here. Yeah, I know I like talking more about network stuff. I don't want to be talking about end user stuff, but it is what it is because this is a pretty good one right here. Windows 11 arrives on October 5th. Android apps will come later. So I didn't even know Windows. My boy actually mentioned that to me on Sunday. Told me Windows. He's like, you tried Windows 11 yet? I'm like, shit, I'm still using Windows 10. I didn't even know Windows 11 was coming out. But apparently it comes out October 5th. Windows 11 is no longer merely coming this fall. Microsoft will begin releasing the new operating system to the public on October 5th, starting with their newer PCs and PCs being sold in stores, and then rolling out to other supported systems over time. Over the next 9 months or so. The company also says that the Amazon-powered Android app support coming to Windows 11 won't be ready for public consumption at launch Microsoft will offer a preview of Android apps in the Microsoft Store for Windows insiders over the coming months. Like recent Windows 10 updates, Windows 10 will have a phased rollout through Windows Update. Most PCs will begin to see and automatically install to the update on October 5th. Microsoft says the new PCs will be the first to upgrade, followed by older compatible PCs, based on intelligence models that consider hardware eligibility, reliability metrics, age of device, and other factors. This laptop probably ain't gonna be using Windows 11. Y'all know how it is with this laptop. I got an external keyboard because of the damn keyboard don't even work. So that's how bad this laptop is. Go ahead and donate to your boy, to my Cash App over there. It's in the link. My Cash App is in my description of this video. Anyway, as with Windows 10 updates, you will be able to download the ISO file to initiate the upgrade yourself. Microsoft also offer tools like the Update Assistant to manually trigger updates. I did that with like Windows 10 or like 8.1. I used to do that. Put it on a thumbstick, a thumb drive, or whatever. We assume the company will provide this system for Windows 11 too. All compatible PCs should be offered the update by mid-2022. So that's what's up, man. Windows 11. I didn't even learn about it until like Sunday or whatever. So now see how behind the times I am. So Cam Newton cut by the Patriots. Oh Lord Jesus, man. Oh well. I mean, I don't know. I don't really watch football like that, but I don't know. I just feel like he did more off the field than he did on the field, man. So I don't know. So I couldn't tell you. With his wardrobe and getting into that little incident with the little kid on the football field or whatever. I don't know. He ain't Tom Brady. I'll tell you that much. So, but anyways, we'll just give it a couple more minutes for some people to tune in. Again, this lab right here is in Packet Tracer. You can get a copy of this from my Discord server. So the link in the chat. Make sure you join the Discord server. Download the lab and we'll do it together. It's a real quick and simple lab. So don't be intimidated by these 128-bit addresses right here. This is the network address anyway. So. What else we got? Let's give it a couple more minutes. We also have that study plan that I've been haphazardly following over there. Not enough backup power. AT&T and T-Mobile suffer big outages in Louisiana. Y'all know it was Hurricane Ida that came and hit Louisiana. AT&T said today that only 60% of its network in Louisiana is working as Hurricane Ida pummels the state. Damn. T-Mobile, who I've got, is reporting similarly extensive outages, while Verizon says it has minimized outages with backup generators. AT&T and T-Mobile both said that they deployed additional generators, but carriers apparently didn't deploy enough to handle the widespread power outages. Jesus Christ, that's crazy, man. Where I work at, we have to supply our, because I'm in Florida, in case y'all don't know, we have to make sure that the data center can withstand these hurricanes. Obviously, you can't just be 100% foolproof, or hurricane proof your data center or whatever, but you got to have, a lot of things in place, backup generators, backup fuel, backup power, all of that stuff. So I'm not too sure what a big ISP like T-Mobile and AT&T doing, but there's only so much you could do, I guess, with with a whole ass hurricane is hitting your state. Our Louisiana wireless network is operating at 60% of normal, and we have significant outages in New Orleans and Baton Rouge. Shout out to the Tigers, LSU. My brother went to school there. Due to power outages, flooding, and storm damage, AT&T said in a network status update, we had key network facilities go offline overnight, and while some have already been restored, some facilities remain down and are inaccessible due to flooding and storm damages. Pray for the people in Louisiana, but y'all know, man, they always be getting hit, man. It's like Haiti with the earthquakes and stuff, man. It's crazy, man. So anyway, let's go ahead and get started. I guess it's just us tonight. So this lab we're gonna be working with. Let's don't get intimidated by this network here. We got a little small. We got the pretty much kind of like the internet or cloud here. Maybe that's a data center, whatever. We're gonna focus on these three guys right here. Routers A, B, and C. Right? These three in the triangle right here. We just go focus on these guys, right? These we're gonna eventually have some OSPF neighbors with these, but we're gonna do configuring on router A, router B, and router C, right? So the tasks are right here. I hope you guys downloaded the lab so y'all can do this with me. Anyway, I'm gonna reset real quick. Reset. So we got the timer going too. And another thing, like Packet Tracer, y'all know it tells you the percentage of how far you've gotten and stuff like that. So anyway, this is the addressing guide right here for router 1, or router A rather. Router B right here, and then router router C right here. In this activity, we'll configure multi-area OSPF. The network's already connected and interfaces are configured with IPv6 addressing. Your job is to enable multi-area OSPF. Version 3, remember, version 2 is for IPv6, and version 3 is for version 2 is for IPv4, and version 3, OSPF version 3, is for IPv6. Verify connectivity and examine the operation of multi-area OSPF. Instructions, configure OSPF version 3. We're going to enable IPv6 routing. Y'all remember how to do that? We did that yesterday in a single area lab. Go to router A, and you see Diane over there will pay attention. You remember what that was? Look like it's just us tonight. So let me just go ahead and run through it, man. You turn on IPv6. We go to global config mode. We say IPv6 unicast routing. That enables routing for IPv6, right? For router for all the routers right there. So notice we're at 2% complete. So once we get to 100, we're done, right? Task B says configure OSPF version 3 on router A with a process ID of 1 and a router ID of 1.1.1.1, right? So y'all remember how to do that, right? Remember last time I said router, what did I do? OSPF. I did OSPF v3, and then I did the process ID of 1, like that. It worked, but that is another way of turning on OSPF version 3, and it works differently. I can't remember what the difference between the two. I've yet to find out what the difference is, but what we need to do is IPv6 and then router OSPF and then a process ID, which is 1. We're going to get this error right here. It says process ID 1 could not pick a router ID. Please configure manually. We didn't put a router ID yet, so that's why we got this error here. So it couldn't come up with that process ID just yet. So we got to come up with that router ID, which is just router ID when you're in router config mode, right? And then the process ID, the router ID they said was to use this right here, 1.1.1.1, right? So we're really similar to the lab we did yesterday. So now we're working with multiple areas as opposed to a single area, right? So quad 1 like that, and notice we're at 5% complete. So we're 5% at this point. We can just show our work so far with show IPv6 protocols, I believe. Yes. So we have just the protocols like that. Don't really give us much information there. So let's go back into that process. Step 2, advertise each directly connected network in OSPF version 3 on router A. Configure each active IPv6 interface with OSPF version 3, assigning each to the area listed in the addressing table. So we scroll up for the addressing table, which is up here. And there's router A right there, right? And then we have these IP addresses right there, right? But don't worry about, remember, I know these IPv6 addresses got your head spinning. At least they got mine head spinning. 128 chock full of bits, right? But with IPv6, we ain't got to worry about all that, right? We just have to, we don't work with network statements, right? So we go back to global config mode, and we're going to go into the interface. So we got these interfaces we need to work with. Gig 01 or Gig 00, Gig 01, and 000, right? So those interfaces there. I'm bring up the chart. So this is the serial interface, right? That's probably 000. One of them is Gig 01. The other one's Gig 00. So we need to advertise OSPF out of that network, this network, and this network, right? So we just need to go to those interfaces and do it. Remember, because it's interface specific. So we go to that interface, Gig 00, and we just type in IPv6, really similar to yesterday's lab, right? So IPv6, OSPF, and then I believe the process ID, which is 1. They told us to use 1. And then the area keyword, so area, and then the ID, the area ID. So gig, what are we working with? We're working with Gig 00. So these are the gigabit interfaces on this side. This is in area 1. So we need to pay attention to our areas here, right? Because these are going to be in area 1, and this is going to be in area 0. Remember, we don't say routers are in an area. We say their interfaces are in an area. So don't say that, or else you'll confuse yourself, right? So area 1 for that guy, right? And notice we're at 16% complete. I think theoretically we should see a neighbor form. There it is right there. We got a neighbor 11.11.11.11. So somewhere in this cloud, somebody got the address of 11.11.11.11, right? That's their router ID. We became a neighbor with that guy right there. So it's either that side or that side. I don't know on the topology, but either way, we became a neighbor with somebody in here, right? So let's go ahead and do the same thing on this side and broadcast OSPF over here, right? So go to router 8, and we're going to do gig 0.1. So interface gig 0/1. Same thing, IPv6, OSPF 1, area 1, right? Because it's in area 1 right here, right? Right here, area 1. Right? And then this side is going to be in, this interface is going to be in area 0, right? So we press enter, boom. We're at 23% complete. So you see, we're racing through this, man. I hope y'all downloaded this lab and y'all doing this with me, man. I know it's just a couple of us in here today. I guess I lost my my momentum when I was streaming continuously. But see, that's how it is when you do a YouTube and stuff like this, man. You gotta do stuff continuously. I took a break and everybody just kind of like fell off the planet. It's all good. I see you, Foster, rocking with me. Somebody else in here, so we gonna get this going here, right? So we got a neighbor 12.12.12.12, right? So we got two neighbors here, right? We got a neighbor here, we got a neighbor here, and we got a neighbor there, right? Those two right over here and here. We can do that with we can verify with just what? Show IP OSPF, actually IPv6 OSPF neighbor. We see we got those two neighbors right there, right? 11.11 and 12.12, right? Let's do the same thing on this interface, area 0. Go back to global config mode. This is a serial interface, right? See there? This is the serial interface right here, as indicated by that red lightning bolt. Interface serial 000, IPv6 OSPF, process ID 1, and this one is going to be in area 0, right? The backbone area, right? That's area 0, right? Backbone area. So area 0. We're at 33% complete, so 1/3 of the way. We're almost done. I don't think we're going to get a neighbor yet because we didn't set up OSPF on this side yet. So we probably ain't going to have no neighbor yet. Not just yet. So let's go ahead. Oops. Whoop. Let's go to this guy. Actually, what's the next step? What's the next step they want us to do here? We did that. Then we did advertise the directly connected networks. And then they want us to do the same thing right here. Repeat steps 1 and 2 for routers B and C. So for routers, router B and router C. So they want us to do the same thing except on those two routers, right? Really similar to yesterday's lab, right? Except we're doing multiple areas. So we got to do it on this interface, that interface, that interface, and give him that process. I mean, the router ID of 2.2. Same thing with this guy, router C. That interface, that interface, that interface, and give him the ID of 3.3.3.3. I'm not going to write a whole bunch of 3s there. So that's a 2 and that's a 3, right? So let's go ahead and do that, right? Go to router B. And I want to show y'all something, right? Watch this. When I just go and turn on, let's go to enable mode. Let's go to global config mode. And then let's just try to turn on OSPF, right? IPv6 router OSPF. And then put in 1, boom, says here, IPv6 routing is not enabled, right? You know what command I'm missing here, right? It's just y'all, I know y'all been paying attention. I know y'all paying attention. So it is, we have to do IPv6 unicast routing. That enables IPv6 routing. Now we can turn on OSPF, right? So IPv6 router OSPF 1. Now we got another error. This thing is just throwing up at us here. OSPFv3 process 1 could not pick a router ID. Please configure one manually, right? Why not? Let's take a look at our interfaces here. Show IPv6, actually IP interface brief. We don't have any IP addresses, so he couldn't pick a router ID, right? See there? He couldn't pick a router ID. Well, what if we do show IPv6 interface brief? Well, look at that. Look at that. We have a bunch of IPv6 addresses. Why didn't they choose those for router IDs? You know why? Because even IPv6, they choose the router ID as a 32-bit address. It looks just like a IPv6, IPv4 address. So that's why, even though we got some IPv6 addresses configured on these interfaces, it chooses a 32-bit address that is configured on one of these interfaces here. But none of them are configured, so that's why it couldn't pick a router ID. So we need to do that. He needs to be 2.2.2.2. So let's go ahead and do that, right? So go back to global config mode, IPv6, router OSPF1, and then give it the router ID of 2.2.2.2. Press enter. We're at 39% complete. You with me so far, y'all? With me so far, y'all? Any questions? Am I losing y'all? Let me know. Hit me up in the chat. If y'all understand it, just let me know, because y'all kind of quiet tonight. That was just a tough crowd, right? So I almost clicked network there. There's no network state. See, look, you don't even have to, you can't even type the word network in there. That's good. I'm glad, man, because network statements, boy. Let's back out of this. And we need to, since we enabled IPv6 routing, we enabled OSPF version 3 with the router ID of 2.2.2.2. Now we just need to do the interfaces, right? So what interfaces we got on router B? Gig 00, serial 00, and serial 001, right? So this interface, these two interfaces right here, right? That's the gig right over here. And these are the two serials, serial and serial, right? Serial and gig, right? With me so far? Y'all with me? All right. I'm just hoping y'all, I always ask y'all that just to make sure y'all paying attention and y'all with me and I'm not losing. I'm not just talking shit over here. So, interface gig 00, IPv6, OSPF. These guys are all in area 0, right? So area 0, area 0, area 0, right? All in area 0, right? He is called what type of router is he? What type of OSPF router is he? Y'all want to know? Or y'all can put that in the chat. Pop quiz of the day. I haven't done those in a while, right? Area 0. We're at 50% complete, so we're halfway done. Let's see if we can knock this out before 8:30, right? Half an hour, right? The other interfaces was serial. Notice we got a neighbor of 21 on our gig 00 interface. So that means we became a neighbor with on a gig 0. This is the gig interface. So we became a neighbor with somebody in this little cloud right here, right? Cloud guy, right? Woohoo! Yay! We became a neighbor with somebody in there, right? Now we need to do serial interfaces. We'll become neighbors with that side, probably this side. We didn't set up OSPF here yet, so we're not going to be a neighbor yet with this guy, not just yet. So interface serial, interface serial 000, IPv6, OSPF1, area 0, right? Really repetitive here, right? Interface serial 000, 001, same thing. Interface, notice we got a neighbor, IPv6, OSPF1, area 0. We're at 65% complete, so we're almost done, man. We're almost done. We're going to knock this out, man. You know, this is probably going to be the shortest stream we had in a while. Or maybe we can knock out another one. I don't know. Whatever y'all want to do. We're almost done. What was the next step? We gave them a process ID of 2.2. So yeah, let's go ahead and do the same thing on router 3, or router C rather. This guy right there. Where's router C? He's right here. Let's go to I was gonna say privileged exec mode, and then global config mode. We say we'll do. We don't want to give him a loop back. We just need to turn on IPv6 routing, right? With IPv6 unicast routing, and then we turn on OSPF version 3, right? IPv6 OSPF. Router OSPF process ID 1. He's going to throw up at us right here and say, I couldn't pick a router ID. All right, well, let me give you one then. Router ID 3.3.3.3. Remember, that's what they said for us to do? Right over here. We said router C should be 3.3.3.3 right there. Press enter. We're at 70% complete. So we almost done, y'all. We almost done, y'all. I hope y'all doing this with me. You can download it. If not, you can download this lab in my Discord server. It will be in the chat below. I'll paste it one more time for y'all. There is the Discord server, so make sure you download this lab so y'all do this with me. If you're behind, you can just replay the stream. It's only about, we're only about 26 minutes into the stream. And the first 10 minutes, I was just talking shit, reading IT news and stuff to y'all. So it's really just 20 minutes. You'll be able to knock this lab out, man. The next step is to go to interfaces, right? So we need to go this interface right there, which is the serial interface, and then 2 gigabit interfaces, that one and that one, right? What are those? Gig 00, gig 01, and serial 001, right? They're going to do that. Interface, well, let's get out of this. Interface serial 001, and we give him the IP address IPv6 OSPF. Almost gave him an IP address. Process ID of 1. Now we need to pay attention to our areas now because it's multiple area, not single area, right? So we got these 2 gigabit interfaces, right? I'll show y'all real quick the topology of my favorite Microsoft Paint, not Visio. The gigabit interfaces, pay attention. Those guys are in area 2, right? The serial interface is in area 0, right? So the difference between area, multiple area OSPF and single area OSPF, right? So we said the gigabit is, the serial is in area 0, which is the backbone area, and we're at 81% complete. We have a neighbor with neighbor of 2.2.2. Who is that? That is this guy over here. So he's .2.2.2. I ain't gonna write a whole bunch of 2s there, but you know that's 2.2. Actually, I'm gonna take that back. This guy is 2.2, right? So now them 2 became neighbors. Them 2 right there, right? Now we got to do enable OSPF on that interface and that interface, and we'll become neighbors with some ISPs or somebody data center that's in area in that cloud over there, right? So now interface gig 0/0 IPv6 OSPF 1 area. That is what area 2, right? Area 2, and then we should have a neighbor coming up right over here, right? Theoretically. While that's coming up, let's go to do the other interface. There it is right there. Interface gig 0/1. I didn't type that right. What is it? Gig 0/1. And give him IPv6 OSPF 1 area 2. And we're at 100% complete. We knocked it out, man. But they also, we should theoretically get one more neighbor coming up. There it is right there. We can verify our work with what? Show IPv6 OSPF neighbor. And we can see this guy got 3 neighbors. Who are they? Let me move this out of the way now. Bloop. Bloop. Y'all hit me that like button, man. Make sure y'all hit me that like button. That way, it'll show up in the, it'll help with this channel, man. And that way more people come into the chat room and help me out and stuff like that. And I help y'all out, and it'll be a better learning environment, right? So we got a neighbor of 2.2.2, who is what? That is this guy right over here. My bad. That's this guy right here. That's 2.2.2. And then we have another neighbor, 31.31 and 32.32, who are somewhere in here, in that cloud right over there, right? What else? What else we got going on here? Bring that back up. Bring that ass back. Bring that ass back. Right here. That's what they wanted us to do here. Use show commands. Actually, I'll take that back. Verify connectivity to each of the OSPF areas from router A. So we on router A, ping each of the remote devices in area 0 and area 2. So they want us to ping this address right here, which is probably B1 is somewhere over B1 over here. So B1 2. So somewhere in here they want us to ping that in here. So from router 8 they want us to ping somewhere in there. That's basically what they want us to do. So I'll go ahead and copy and paste that and then ping that, right? I think you got to do ping IPv6, so we got to go to router A to do that though. So go to router A, which is right over here, and have him ping that address. Ping. So we're just doing basic connectivity. The lab's pretty much done. They just want to show that it worked, right? Ping. Well, you got to do IPv6 like that. Paste that address. Just enter. And we got to reply 100%. Good to go. Good to go. Let's do the same thing on the other ones. Pretty sure they'll work, but we'll see anyway. Who is A1 So A1 is somewhere in here. Let's see. A1. That's A1. The other one's going to be A2. So we're going to be pinging that way, pretty much. So we're going to be pinging from here to there. Somewhere in there, using this interface right there, right? Or whoever that neighbor is, right? So we go there and then ping IPv6 and then the IP address, which is that right there. Paste. We got to reply. So we good to go there. I'll ping one more just to show y'all real quick, right? I'm pretty sure they made it work. So this was the one that's ending in A2, which is somewhere in there. There it is right there, right? So we're going to be pinging from router A to there, right? Because this is the IP address that's ending in A2 right there, right? So we're going to be pinging right there. Let me draw a better arrow for y'all. Back to router A. God, man. Ping IPv6 Is it that address? My bad. Is that the right one? Yeah, A2, and we got a reply. So I'm not going to do the rest of them. Y'all go ahead and download this lab, and you can ping the rest of those right there. We got to use some show commands. They want us to use show commands to examine the OSPF version 3 operation. Use the following commands to gather information about your OSPF version 3 multi-area implementation. We'll just show IPv6 OSPF to see our implementation here, right? So we'll just copy and paste that bad boy, right? Paste show IPv6 OSPF. So this is real similar to what we did yesterday, right? Remember I did show IPv6 OSPF, and it shows us how many times the SPF algorithm was executed, which is over here. We see how many interfaces are in which area, right? This is area 1, which is where? Over area 1, right? So router A has how many interfaces in area 1? Should be 1 and 2. Should be in area 1. Let's see. Is that what he says? Let's go back to that router. Where is he at? Yes, right there. We got 2 interfaces in that area. And then in the backbone area, we have 1 interface in that area. And that's indicated right over here. See? We got that 1 interface right there. What else could we see there? We got a bunch of other LSA information, some checksum information. What else we got here? We have our router ID that we created. Remember we did that. How many times these LSAs and the timers and the flooding and stuff like that of the LSAs, the number of LSAs we received. Let's see if it'll come again, right? Let's run that again. The number of LSA 12. It executed 8 times that time, and how many times before? Still 8 times. 8 times in there. What else can we do? Let's do show IPv6 route. We'll run those show commands and we'll call it a night. Let me see. Where are the timers? Oh, that's a good question. Where are the timers? That's what we did yesterday, right? I want to say they're in this command right here. Good question, Foster. Show IPv6 OSPF interface. We'll do that real quick. Paste. And remember, we had 3 interfaces that's participating in OSPF, right? These guys right here. This is from router A's vantage point. He got that interface in OSPF, this interface in OSPF, and this interface in OSPF. Version 3 now, right? This is for IPv6. The timers are in that command right there. Show IPv6 should be there, right? Because we see right there, timer intervals configured. Hello 10, dead 40, wait 40 also. That is for what interface? That's for gig 00. What else we got? We learned about the router we learned from this interface, gig 00, 11.11.11, right? That router is BDR, backup designated router, right? This is a broadcast network. What else do we see about this? That's just this interface now, gig 00, which is somewhere over, bloop, where's he at? I believe it's probably going to be this one right here. It's one of these two, because those are the gigabits, right? And this is the serial, right? Remember, the serial is usually indicated by this little lightning bolt, right? But that's the timers. If that's the ones you're looking for right there, Foster. What else? What else we got here? When the hello timers are due. All this other superfluous information here. Adjacent with neighbor 11.11. Who is a designated router? What else we got here? Gig 01 would be the other gigabit interface. We learned about the router 12.12.12. That's also somewhere in that cloud to the left of us. The interface ID, transmit delay. What else we got? The timers that are configured. Is that the timers you're asking about? Because I believe that's the timers that we're looking for. Or probably that's what we were looking for in Boson NetSim before I fucked it all up, right? And adjacent neighbor. Here's a serial interface, right? So this is going into the area 0, backbone area, right? We have, what do we learn about this? This interface ID number 4. So this is right here. I'll show y'all. This is serial interface, right? We're going to focus on this interface. This is the serial interface right there. Serial, what is that? 00, 01, whatever. This is serial interface, right? He is in area 0, right? Right over right there. So area 0. The process ID of 1, we've configured that. Instance ID 0. Know what the hell that is, but whatever. Router ID is 1.1.1.1. That's me. That's this guy. He is 1.1. This guy right here, he is 1.1.1. I'm trying to figure out which way to go. He's 1.1.1, right? This guy was 2, right? And this guy was 3. I'm not going to write a whole bunch of 2s and 3s for y'all, right? What else? We have, remember, serial interfaces. Their default cost is 64. It is a point-to-point network. By default, serial interfaces are considered a point-to-point network. We have a transmit delay there. Timer intervals that are configured, which is 10. So pretty much similar to IPv4, OSPF, 10, 40, 40. Retransmit 5. When the hello is due, we say hello what? Every 10 seconds. We can watch this in action, right? Watch, right? We'll go back to the serial interface. Actually, let's narrow it down to the serial interface. Serial, let's see. Serial 00, or is it 000? 000. So 0 like that, right? We'll see right there. We're narrowing it down. Here, I'll clear it real quick. Clear the screen. Just that interface. Just that interface we're focused on. So we have everything in there, right? So that way you ain't got too much throwing up at us here. We'll move this out of the way. What we got? We said it was a 000. We know it's up. This is the link local address. Interface ID. We said it's in area 0. The process ID that we came up with. Remember router, IPv6, router, OSPF1. That's what that is. Instance ID. Not too sure what that is, to be honest with you. I guess each process ID has also an instance ID. Instance of OSPF, right? This is the router ID we've manually configured. We said serial interfaces are point-to-point. Default cost is 64. Same thing here, same thing here. Default timers. We said, since we said that the hello timer is 10 seconds, the next one is due in 9 seconds, right? We run it again. Well, it's starting over, right? 2, 1, 0, 10, 9, right? 8, 7. We'll have a countdown timer just like that. And then when it's due, once it receives one, it resets that timer. That's what that is right there, right? Index 3 out of 3. I don't know what the hell that is. We have all this other superfluous information right there. Neighbor count is 1. Adjacent neighbor count is 1. Know what the hell that is. If you want to break some of this stuff down, you can go ahead and do that on your own. Maybe I'll look into this on my own as well. I'm not going to sit here and harp on. We're at 40 minutes into the stream here. Let's do one more. Two more. We already did neighbor. I'll do it again, right? We said router A should have 3 neighbors, right? What neighbors are those? We said it was we said it was this sorry. We have a neighbor through here. We have a neighbor through this interface. We have a neighbor through this interface. So if we run that command, theoretically we should see 3 neighbors, right? So show show IPv6 OSPF neighbor, and we'll see there it is right there, right? There's 1 neighbor, there's the second neighbor, and 2.2.2. That's this guy at the top. That's him, right? So one more command. This one will show us all the LSAs, right? Link state advertisements, which fill up our link state databases. There's a whole bunch of them. I have yet to memorize them still. So what's that? Show IPv6 OSPF database, and this is the type 1 LSA, right? We are receiving them from 11.11.11, which is on the gigabit interface. 12.12.12 is also on the gigabit, and then 1.1.1, which is us. We are the advertising router. That is the advertising router for that. I believe this is a link state. I'm sorry. A type 2 LSA, if I'm not mistaken. Type 2. I believe this is a type 8. No, that's type 8. And what is this one again? This is link intra-area prefix link. I can't remember what type that is. I can't remember what that type that. I believe that's type 9, if I'm not mistaken. That might be a type 9 LSA. I can't remember. Y'all put it in the chat if y'all know what that is. Refresh, because I'm losing y'all. I'll be losing. I'm sorry if I'm not ignoring chats or whatever. It's just sometimes it freezes. They said the chat was disconnected and stuff. So, okay, good. Y'all with me still. So, what else we got? I wish the LSAs would do it just like this on all of them. See, that tell you right there. This is a type 8 LSA. Type 8 LSA. Now, I'm going to tell you exactly what it is. And I believe that's inter-area LSA. I can't remember. I just watched something like that on with Keith Barker on CBT Nuggets. But I can't remember. We know that this is router type 1, which is flooded for area 0. This one is type 1 for area 1. This type 2 for area 1. Inter area. Yeah, I want to say, I can't remember. That's definitely type 8 as is written right there. Can't remember which type this one is. But yeah, that's pretty much it here. Packet tracer output for show IPv6 protocols is currently not aligned with iOS version 15 output. Well, neither is Boson NetSim. We did that yesterday. Referred to the physical equipment labs for correct show command output. But anyways, we're done with the lab here. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Y'all make sure you hit me with that like button. Make sure you subscribe so that way you know when I'm streaming. Sometimes I'll cancel and I'll put it, or I'll move my stream to another time or whatever. I'll put it in the Discord server. So make sure you join to the Discord server, the chat. The invite is in the chat right there. What else we got going on? I will try to stream tomorrow again at 8 o'clock. I noticed I said try because, like I said, I've been busy with work and stuff. But yeah, that's pretty much it for now. Comment, like, subscribe to the network.